Hi, welcome to another session of Circuits and Networks. In today's class 15 under transient analysis of RC circuit, we will be using the mathematical approach, that is differential equation method and Laplace method, in order to find out the solution for RC circuit when it is excited by a DC source. So from our previous classes, you know that whenever the switch is closed after t greater than 0, the current through the RC circuit, it is dropping in nature. So we have to see whether we are going to get the same output when we go through a practical approach. For that, let us go with the previous sessions. That is, when the switch was open and when the switch is closed, the conditions of current or the conditions of voltage, when you talk about the RC circuit, when initially the switch is open, no current flows through the resistor and capacitor. That is obvious. And when the switch is closed, current starts flowing in the closed circuit, and capacitor initially acts as short circuit, and hence initially the current through the circuit would be V in by R. So this is the instant at t equal to 0 plus condition that you need to keep in your mind. Okay, so the initial current is V in by R. Okay, for t greater than 0, the standard equation that you can derive by applying KVL to this closed circuit, that is minus V in plus R into I, that is the current, and the voltage across capacitor is given by 1 by C integral I dt equal to 0, and framing this as equation 2 and differentiating this equation 2 with respect to t, I'm going to get R di by dt plus I by C equal to 0. This Vn is a DC source, that's why when you apply the differentiation to a DC, it will give you the value as 0. Hence, we are left over with equation, that is di by dt plus I by RC equal to 0 as equation 3, which is a linear differential equation of first order, and this is also known as the homogeneous differential equation. And the solution for this is obtained as I of t is equal to k e to the power of minus, this we are going to treat as mathematical equation p, that is p is replaced by 1 by rc into t, and k can be obtained from the initial conditions. And initial conditions, what we have seen, I of 0 plus is nothing but the value of uh, current immediately after the switch is closed is V in by R. So with that, I'm going to get the value of K as V in by R, and I'm going to substitute in this equation, and I'm going to get I of t is equal to V in by R e to the power of minus 1 by RCT. Now, if at all you look into this equation 4, this is a exponentially decaying curve. So for this, we're going to get the waveform in this fashion. There is a curve which is drooping in nature, exponentially drooping in nature. So this analysis we have done with the differential equation approach. When you see the voltage across resistance, that is given as R into I. So R, the value, and I value, when you are going to substitute, you're going to get VR, that is the voltage developed across resistor, which is nothing but equal to V in e to the power of minus t by RC. Let me treat this equation as 5, and voltage across capacitance will be 1 by C integral 0 to t V in by R e to the power of minus t by RC. This is the current value, and when you substitute the integrations, we can determine the value of constant K by taking the initial conditions. And at initial conditions, the capacitor voltage was 0, so K becomes V in, and hence Vc will be equivalent to minus V in e to the power of minus t by Rc plus V in, and on the whole, the voltage across capacitor would be equivalent to V in of 1 minus e to the power of minus t by Rc. Means was the capacitor is completely charged at steady state conditions. This we are treating as equation 9. Now based upon equation 5 and equation 9, I am going to get the voltage across resistance, which is also drooping in nature, whereas voltage as capacitor is quite increasing in nature. Why? The capacitor has completely charged to the voltage which is supplied by the DC source. Now, if at all you look into the practical approach for a MATLAB circuit, here you can see the two circuits over here. For this, what we have done, for switching conditions, I have used here a diode. So without diode, if at all you want to calculate the voltage across resistance, voltage across capacitance, and current through the circuit, what is the output you are going to get? What is this 100 and what is this 99.17? And difference between these two circuits is the application of a switch, which is a diode over here. Okay, so for a particular uh, time value of 0.04 second, if at all I run this circuit with resistance value as 50 ohms roughly, the resistance I am taking the value as 50 ohms, the DC value of voltage is 100, okay, and the capacitor value is 100 microfarads. The same case I have taken in the secondary circuit also. First, let us look into this particular circuit, the outputs. You can see 100 is the value of voltage which is across capacitor. So if at all you look into this waveform conditions, since it's an open circuit, the current is zero. Current is zero indicates that the voltage across resistance is also zero, because uh, according to the analysis of resistor, the current and voltage waveforms will be the same. Fine. But voltage across capacitor is 100 volts. So that is a catch over here. Anyhow, when you look into this practical network, when the diode is applied, how the waveform would be? You can see the current waveform, it is decreasing to zero. Therefore, resistance voltage is also decreasing to zero. But capacitor is slowly charging to 100 volts. So this is an important factor what we need to understand about the transients concept. How the behavior of the capacitor would be at initial, at final. So initially the value of voltage across capacitor is 0. Simultaneously the value of current is high. Fine. Why 2 amperes? Because 100 divided by 50. 100 divided by 50 is the value is 2. So that's why the current value is decreased from 2 to 0. Okay. If at all you remove this diode, I'm going to get the output like this. So we can compare the outputs of both the circuits like this. So this is a condition without switch, and this is a condition with switch. So this is how you can understand the behavior of RC circuit. In our previous class, we have seen the same analysis with RL circuit. So I request you to comment in the chat box whether you are able to understand this concept with the help of MATLAB approach. So when you see a practical circuit application for a circuit without a switch, this is what the output we got, and with switch, this is how the output we got. And the theoretical analysis, as I have seen you, I have make you to show showing this the current through the circuit, voltage across resistor, voltage across capacitor. These waveforms are quite similar to the practical waveforms in the MATLAB. So this is how you study the transient behavior of RC circuit. So I hope you like this particular video. Please share among your friends, subscribe to this channel and press the bell icon for the future notifications. Thank you.